Okay, so logarithms and exponential functions, right? So how to graph these. So these right here, right, these are the important points. I'm going to write them on here, 0, 1, and 2, and we also have a negative 1. Now to get the y values, this is the one that's a little bit weird. I'm going to have to ask you, well, what's 2 to the negative 1, 2 to the 0 power, 2 to the first power, 2 to the second power. Right, what is 2 to the second power? We know that.
4.
4, great. What's 2 to the first power? 2. Now, the weird one for most of you is what is 2 to the 0 power? I kind of talked about it like a couple of weeks ago. Any number to the 0 power except for 0, it's 1. That's the weird part. Alright, so any number other than 0 raised to the 0 power is 1. Alright? Now, the other weird one after that is that once you have negative exponents or negative powers, that's going to start getting smaller. So this is actually 1/2. Right, so 2 to the negative 1 power is negative 1/2. Now, I'm not going to use that number, but if I had 2 to the negative 2 power, that's the same thing as 1 over 2 squared, which would be 1/4. Okay? Again, I'm not using that number. I'm just showing you that I could smile. What do you think 2 to the negative 3 power is? What is 2 to the third power?
1 over 8.
Right, 2 to the negative 3 would be 1 over 8. And if I keep picking those, it just keeps getting smaller and smaller and smaller and smaller fractions, right?
Like thousands and stuff.
Yep, all the way. So it'd be like 1/8, 1/16, 1/32, 1/64, 1/20, 1 over 28. Does that make sense? So it keeps getting smaller and smaller. But it'll never be 0. All right. Anyway, so that's what I'm going to write here. So 2 to the 0 power is 1, 2, and 4, and this would be 1/2. All right. I guess notice that the x values are the exponents, and the y values is what I got when I did that. Function, this equation. Okay, so let's graph it. So we have 0, 1. That's obvious. That's the most important point that I always look for. 0, 1, 1, 2. So from here, 1, 2 is right there. From here we have 2 4s. So 1, 2, 1, 2, 3, 4. All right, and then we have negative 1, 1/2, and that is this, and this one is that. All right, now it turns out that we have, remember how we said, and he kind of said it, I said, what's 2 to the negative 3 power? He said 1/8. 2 to the negative 4th power would be 1 over 16. Then the next one would be 1 over 32nd. The next one would be 1 over 64. My point is, no matter how many times I split that, it's never going to be 0. All right, so we have what's called a horizontal asymptote right on y is equal to 0. All right, so this is called a horizontal asymptote by y is equal to 0. Kind of weird, right? Because this is the x-axis, right? But the x-axis is actually y is equal to 0. What's the domain of this function? How far to the left? How far to the right? It is all real numbers, all right? So all real numbers because you go infinitely to the left, and as you go up, you cover more of the right side, all right? Now the range is the one that's weird. Now remember I told you it cannot be 0. See, the asymptote's at y is equal to 0, so it cannot touch that, but it doesn't drop below that line either. So we can write it two ways. We can say the lowest point is 0, not including 0. Notice that I'm writing a parentheses. And the highest point is infinity. Or we can say y is greater than 0. Either one you want to use is fine with me. You with me? All right. So that one perhaps is not too bad, but the logarithm is the one that's really strange because there's no way for me to get those points unless I use this point. So you're going to see what I mean. All right, so recall that the exponential and logarithmic functions are inverses of one another. And I talked about this at the very beginning of the lesson when we talked about all the parent functions that we had. All right, so they're inverses of each other. Therefore, to graph the logarithm function, you must switch the x and y's. The x's and y's, I guess, to get the points for the table. So what do I mean by that? You see those points right here, negative 1, 0, 1, and 2 for the x. Now this is going to be my y. So this would be negative 1, 0, 1, and 2. And my y's on the exponential function, whatever is y, now is going to become the x's. So I have 1/2, 1, 2, and 4. Alright, so let's graph this. We have 1, 0, 2, 1, which is right there, 4, 2, 2, 3, 4, up 2. And then we have a half and negative 1. A half would be right here, negative 1 would be somewhere around there. But just like that other one has a horizontal asymptote, and turns out that the logarithm has a vertical asymptote right through the origin. Okay? So we have an asymptote right through the origin. So it looks like that. What is the range? I think the range is easy to see. What do you think the range is? All real numbers. Alright, because it goes forever down, forever up. Now there's an asymptote. This is called a vertical asymptote, and that will be located at x is equal to 0. X is equal to 0 is this line right here, down the middle. Alright? Now the domain, it doesn't go past this line. Okay? What is this line right here? It's color coded. X is equal to 0, right? And it goes to the right. To the right, is x getting bigger to the right, or is it getting smaller? Are these numbers getting bigger or smaller as you go to the right? They're getting bigger. Alright, so because of that, we can write x is greater than 0. Notice that I did not write equal. I cannot write equal to because of the asymptote. Or between 0 and positive infinity. However you want to write it, it's fine. Alright, the point is it has to look like that. Sweet. Anyway, that's that. Are we good? Alright, so let's go to the back here as we carry our heavy cross. Alright, according to what you remember, what happens if you have a 2 in front of the actual function? Stretch. So this is a vertical stretch. Vertical stretchy stretch. Trademark. Alright. Vertical stretch. What about the second one? X plus 3. It's kind of weird, right? But if it's in the power, that's going to move it left or right. So now that we know that, is this going to be left 3 or right 3? Left 3 because x lies, correct. So if that's the case, then this one's going to be right 3. Alright, so I'm going to go through this pretty fast now. What happens if you have a number out here? Plus 1. Up 1. And just like before, if you have a negative, that's going to be reflect over the x-axis. And down 5. Am I still on screen? Yeah. Alright. Right on the next one, for the logarithms. For the logarithms, rewind. Alright. If it's inside the parentheses, alright, then you're going to move it left or right. So notice that these are very similar to one another, right? But this one is actually telling me to the right one. But if I have no parentheses, then that means down 1. Alright? So remember, if you have parentheses, left or right. If it's outside the parentheses, it's up or down. Got it? Reflect over x-axis. So remember, it's going to be reflect. So if you had, like, if this was, my hand was the function, you would just kind of flip it over. Okay? That means to the left one, which is kind of repetitive by now. So left 1, up 1, vertical stretch. Vertical stretch by a factor of 2, but normally I just write vertical stretch 2 because I don't want to write by a factor of 2. Alright? It's too hard, too much writing. I'm not an English teacher, as you can tell, because I can barely speak English. Alright. Okay, so notice that they're going to be the same. Okay, so the hard part, I think, becomes graphing these according to all of these. Alright, so let's take a look at one without a calculator. Let's first talk about what type of changes I have. This is a vertical stretch, right? Vertical stretch by a factor of 2, and this is up 1. Remember, it's outside, so it's up 1. Now, what I'd like to do is put that point. So now that I know it's just up 1, that's all it is. I'm going to go up 1, and I'm going to put a little cross here that represents my new axis. All right, so that's going to be my fake origin. All right, normally when I have that, because this is a logarithm, sorry, not a logarithm, an exponential. An exponential has a horizontal asymptote. So normally after I do this, before I start writing anything down, I put my horizontal asymptote going through that little cross. You with me? Now, I'm going to rewrite the points here. And those points are hard to remember, so I'm probably going to write those points for you, because those are the hardest ones to remember. All right, this will be -1, 0, 1, and 2, and this will be 1/2, 1, 2, and 4. Okay? Now, what does that do to it? Stretch by a factor of 2, right? So if I multiply each one of these by 2, I would have 1, 2, 4, and 8. So those are the ones in pink right here. These right here are my new y coordinates. So going back to this right here, where my fake origin is located, my first point, the one I really look for all the time is the one with the 0. 0, 2. So from here, that's 0, and then up 2. Ta-da. The next one, you have 1 and 4. So from here, over 1, up 4. And the next one, 2 and 8. From here, that's the fake origin, 1, 2, and up 8. 1, 2, 3, 4, 5, 6, 7, 8. Might be a little overkill here, but this is, I think, where it helps. And also, I guess we can graph the next one. Was it -1, 1? So from here, -1, up 1. So we're right there. It helps to kind of know what the exponential function looks like. Alright, so when you hear somebody say it grows exponentially, or in a science class when it talks about bacteria growth, if it grows exponentially, it means that it starts really slow and then all of a sudden it gets really big really fast. Okay, so that's what that means, right? Domain for all of these are going to be all real numbers, alright, because it goes to the left and to the right forever. Now the range is the one that's going to be different. What's the lowest point on this? Yeah, this line right here, right, which is 1. So we can write 1. It has to be in a parentheses this time because they have a horizontal asymptote by 1 to infinity. Or you can say y is greater than 1. So you don't have to write both, just one of them. Right? So my asymptote again is located at y is equal to 1. And on an exponential function, that is given to me by this number normally. That number and that number should be matching. Okay? Now, next up. Number 2. Now, I can hear your music from here. Just take it off. Oh, it's her. Who is it? Whose music am I listening to? Turn that off, girl. What do you think? We're in a club or something? No, we're in board math, okay? We're going to be bored. By golly, if I'm bored teaching this, you're going to be bored learning this. All right. Yeah, pay attention. All right, next up. So this one right here, we have a reflection, left 3, down 5. All right, so the important thing is going to be left 3, down 5. So left 3, 1, 2, 3, down 5. 1, 2, 3, 4, 5. All right, so I'm going to put a little cross here that represents my fake origin. This is a exponential function, so we have a horizontal asymptote right there. Same points that we had before, -1, 0, 1, and 2. 1/2, 1, 2, and 4. Okay? These are the points that I gave you at the beginning. Don't stare at me like you don't know what you're talking about. Alright. So that's are the ones now because it's being reflected. Alright, because this are being reflected, I'm actually gonna switch. I'm gonna switch all of these, man. Alright. I'm going to switch all of those to the opposite sign, which in this case they're all negative. Alright, so be aware of that. So now from that point right here, notice my first point that I always look for is the one with the 0. So 0, -1. So from the fake origin, I have 0, -1 is right there. The next one, 1, negative 2. So 1, negative 2 right there. And then the next one, I'm not even sure it'll fit, but 2, negative 4. So 1, 2, 1, 2, 3, 4. Okay, whatever. Good enough. Right, it looks like this is being reflected. My domain is all real numbers. My range, what's the highest point? Right, negative 5. The highest point in this would be negative 5 without including that. Okay, so let me write this is my asymptote. Y is equal to negative 5. And I'm just going to circle these. So remember, they have to be the same. All right. And then the range, the highest point is negative 5. The lowest point is negative infinity. So between negative infinity and negative 5. Or y is less than negative 5. Right? It's less than negative 5 because it's below that line. You cool with that? You may not be cool with that. I don't care. All right, moving on. Whee! All right, logarithms. Yay! Logarithms. They're terrible. They're awful. They're not that bad. All right. What's happening? What translations are happening here? Negative. What does that mean? Reflect. Inside the parentheses, I have a -1, which means I'm going to move right 1 and then up 2. Right. So let's concentrate. Right 1, up 2. So right 1, up 2. We're going to put the little cross right there. Now, the logarithm, the L, the actual L on the letter on the word log, reminds me that I have to have a vertical asymptote. So in this one, I have a vertical asymptote. So think logarithm with the L, right? So like logarithm. You know what I mean? So that's how I remember it. That's why I keep them apart. The exponential, I don't know how to tell you. You're screwed. You have to remember that one on your own. All right? So I'm being reflected. Now I'm going to write the points for the parent function, which are 1/2, 1, 2, and 4. And this will be -1, 0, 1, and 2. Because I'm reflecting, right, I'm going to switch the signs on all of these. So this is going to be a plus now. Negative, negative. Don't put anything with the 0 because the 0 doesn't change. 0 is still 0. All right, so now we're going to graph this. So we have 1, 0. That's actually the most important point for me. 1, 0. So we're right here. Then we have 2, -1. So from here, my fake origin, over 2, down 1. All right, now I have 4, -2. So from here, 1, 2, 3, 4, -2. And that's kind of the weird one. Okay, now that I have those 3 points, I kind of know what that's going to look like. It's going to look like this because it's being reflected. Right, so that's the way it's going to look. So you might want to at least have an idea of what the log and the exponential look like. Because I have a lot of students that put those 3 points, but then you can't connect them. You don't know what you're doing. You just do some kind of squiggly, which then forces me to kind of run. All right. Domain. Does it cover everything left to right? It doesn't, right? But this line right here tells me that's the starting point. My smallest or the farthest left point would be 1. And then it goes to the right forever. So that would be 1 to infinity, or x is greater than 1. All right, again, same idea as that other one. This right here is also going to tell me my asymptote, which is x is equal to 1. Notice it does have to be the opposite sign. Okay, that's the only difference. What's my range? All real numbers. Very good. All right. Now let's pretend we did number 4. We're not. All right, because I'm getting incredibly bored by now. Let's go to the back, do a few of these. All right, so let's make sure we understand one another. Now, if I start with the logarithm, all right, if I start with log base 2 of x, and I shift 3 and up 2, I have to write the left shift inside the parentheses. All right, x is a liar, x lies, so it's going to be the opposite. And then we're going to go up 2, so up 2 like that. All right. On the next one, it says reflect across the x-axis. We know that has to be a negative. So we have y is equal to negative, stretch by a factor of 2. So write the 2 in front. Shift to the right 4 and down 3. So since this is a logarithm, I write that right 4 is minus 4, and then down 3 is minus 3, like that. Alrighty then, let's do number 3. We're going to start with 2 to the power of x, reflect across the x-axis, so we have a minus. Okay? And we have shift to the right, so make sure that on this one there's not really a parentheses, you just have to write it up there. We have to write it as a power, so when it says to the right 6, we're going to write a minus 6 up here. But it's kind of weird, so that 6 becomes part of the power. You okay with that? You may not be okay with that. You might be like, what's going on right now? That's okay. Make sure to ask me questions. Number 4. Start with y is equal to 2 to the x power. Shift left 1, down 7, shrink by a factor of 0.5. Now, I don't know why they put the shrink all the way over here, but that's what goes first. Right, so I got 0.5. Now 2 to the x power, I have to write that in parentheses like that, so I don't get that confused. Shift left 1, so I have a plus 1, and down 7, so I have to have a minus 7 like that. Alright, last but not least, this one right here, I have y is equal to, let's see, reflect across the x-axis, so we have a minus, stretch by a factor of 5, log base 2 of x. There's no left or right shift, so that's it. Right, let's go to your homework. Let's do a few of your homework. Because I'd rather do the homework for these instead of actually, you know what I mean, kind of get you ahead, if you will. So let's move this. Let's take a look at this. Let's see. Between 1 and 3, which one do you want me to do? 3? Is that what I heard? The what? That's why I said between 1 and 3, kids. 1? Okay. Sounds good. Alright, so first, I'm actually going to write those points up here because this one actually does give me a little bit of trouble. It's not very intuitive to me a lot of the times. So these are the points for the 2 to the x power, an exponential function. So I'm going to write that at least once here. And I guess I'll write the ones for the logarithm also. Okay, so I'm going to write those two so I remember, but for this one I need that one, alright? So remember that this one right here, I'm going to shift to the right 1 up 2. So to the right 1 up 2 is right here. Okay? Now remember, this is an exponential function, so that means that I have a horizontal asymptote right here. Right, so that's my horizontal asymptote. Now remember the points. Normally I have 0, 1, right? But this is being stretched by a factor of 3. So my first point should be 0, 3. So from here, pretend that's your fake origin. You're going to go up 3. Okay? The next point should be, well, I'm almost done really at that point. I have 1 and 2. So now that's going to be 1 and 2. 2 times 3 is, what's 2 times 3? 6. So from here, I'm going to go over 1 and up 6. So 1, 2, 3, 4, 5, 6 is right there. Now, the other points are really not going to fit. I guess this one might. -1.5. That'll be -1 and 1.5 would be right there, if you will. But let's say you don't know that. This is where it helps to know. It helps to know what the exponential function looks like this. Because sometimes it's hard, right? The 3 points sometimes is not enough. All right, so make sure you are able to remember what the exponential function looks like. What's the domain? All real numbers. The range should be y is greater than this guy over here. Y is greater than 2, or between 2 and infinity. All right, let's do one of the ones between 4 and 6. Which one?
4.
4?
6.
6? Yes. 6 has more numbers equals harder. All right. But yeah, this is, in terms of everything, this might be the more difficult one. So our first point is going to be to the right 1, up 2. So we have right 1, up 2 is right here. Remember this is a logarithm, which means we have a vertical asymptote. Okay. So that's where I'm going to start. Now remember, the points normally are up here. I'm going to show them to you if you're watching this on video. My first point I always look at is this one. 1, 0. That's still going to be the same because even if it's stretched, it doesn't matter, right? 0 is still going to be 0. So from here, 1, 0 will be right beside that cross. Right, the next one should be 2, 1, but now it's going to be 2, 3. So from here over 2, 1, 2, up 3. 1, 2, 1, 2, 3. And then 4, 6. So from here, 4, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. It helps if you know what the logarithm looks like, which means you're going to try to hug the vertical asymptote, and then you're going to keep going that way. Alright, so that's what that looks like. What's my range? All real numbers, 50-50 chance. Now, what's my domain? Definitely 1's included in that, right? Because I have, see, there's my vertical asymptote, and I go to the right, so I can write this as x is greater than 1. Because remember, to the right, the numbers are getting bigger. All right? What else? Okay, let's just look at 7, 8, and 9. All right, let's quickly talk about what those look like. What does 9 look like? With your arms. Yeah, like that, touchdown, right? That's the quadratic. Now this one is kind of different. You know, what about number 8? What does that one look like? That was a linear function, all right, before we go too crazy. See, there's no square, there's no cubic, there's nothing. So this is the one like in Algebra 1 that you remember all the time. This is a negative, this is a negative line. This is a negative slope, right?
Is this the easiest one?
The what now?
Is the easiest one?
Yeah, so this is, you know, a y-intercept of 3, so you start at 3, and then you go down 1 over 1, down 1 over 1, down 1 over 1. I don't really want to change that for you because that can become confusing. And then finally, number 7, I don't really have a way for like arms-wise to show you that. It just looks like this. It looks like the one on the very, where did I put it? It's right here. Sorry, it's kind of messy. That one. All right, so that's the one from yesterday. So if you don't remember how to graph this, remember, this means to the left 2, down 3, right? So to the left 2, down 3 would be right there. And from yesterday's lesson, we know that this is where my horizontal and vertical asymptote are located. Do we have, is this being reflected? You would have a negative out here in front of it. You don't have anything. Right, so, wow, somebody's being killed over there. Alright, I'm sure I'll watch it on video later. Alright, so this is 1, 1, negative 1, negative 1. Alright, so if it's not being reflected, those are the 2 points. So that's that. This is this. So I guess the only thing that's good about the type of function, the rational functions, is that they're never stretched on this test. They're normally not stretched, so that's what it's going to look like, okay? Let's go to the back now. Let me stop here, actually. Let me stop the video.